Good morning, students. Now let us start the chapter hydrocarbons. So the definition of hydrocarbons is the compounds which are prepared from carbon and hydrogen are called as hydrocarbons. There are so many applications of hydrocarbons, importance or applications. Especially, these are used as fuels. Example, methane is used as biogas. Butane is used in liquid petroleum gas in our gas cylinders, and kerosene, diesel, gasoline, etc. These all also contains mixture of hydrocarbons. Right, and other application of these hydrocarbons is used in preparation of polymers. Polymers is nothing but polythenes, polythene bags we use, polyesters, cloth, etc. So these are the applications or importance of hydrocarbons. Before going into the details of the chapter, I would like to discuss or recollect the classification of hydrocarbons. Hydrocarbons broadly have been classified into three types. In one way, the saturated hydrocarbons. The second, unsaturated hydrocarbons. And the third one, aromatic hydrocarbons. In saturated hydrocarbons, you will get an example of your alkanes. I mean those compounds which contains only single bonds, and in this again simple alicyclic and cyclic hydrocarbons alkanes you can find. Alicyclic and cyclic alkanes we call. In unsaturated you can find alkanes, alkenes and alkynes. Aromatic hydrocarbons already you know, benzene, those all cyclic systems having aromatic compounds or aromaticity or aromatic hydrocarbons. And in this chapter we are going to learn about these alkanes, alkenes, alkynes and aromatic hydrocarbons in detail about their nomenclature, preparation, properties, etc. Right. So first we'll move on to the alkanes. First one, alkanes. These are the saturated hydrocarbons having saturated hydrocarbons having carbon-carbon single bonds. Can be open chain or cyclic system. Cyclic we said cyclic alkanes. Alicyclic means open chain, long chain systems. These are also called as paraffins. Actually in Latin it is called as param, means little, affin means affinity, means little affinity. That means they are actually inert in under normal conditions. They are less reactive, less react with the other compounds and all. Therefore, less affinity, less reactive, less affinity. Therefore, they are called as alkanes. So, coming to the structure of these alkanes, and the general formula of these alkanes is CnH2n plus 2, where N is 1, 2, 3, 4 number of carbon atoms. 1 carbon atom, 2 carbon atoms, etc. Right? CnH2n plus 2. Then we'll move to the structure of alkanes. So as you know that alkanes contains only single bonds, and therefore they are sp3 hybridized. sp3 hybridized means, what is that? Carbon is belongs to your fourth group, the having atomic number 6, 1s2, 2s2, 2p2. So only 4 electrons in the outermost shell. So 4 electrons, these 4 electrons in the excited state of electronic configuration, in excited state, if you see 1s2, 2s1, 2px1, 2py1 and 2pz1. Therefore, it can form 1, 2, 3, 4 bonds. That is, it's called as tetravalent. Tetravalent because, or its valency is 4, because it can share with these 4 electrons with the other atom. A chemical bond is formed by the sharing of two electrons, sharing of 1 electron from one atom and other electron from other atom. So these 4 electrons will be given from these carbon atoms, and 4 electrons from the other atom will share to form 4 bonds. Therefore, carbon can form only 4 bonds. No any extended covalency, nothing. Anywhere you write carbon atom with 4 bonds only. Now, we'll move to the next topic, structure of alkanes. Structure of alkanes, already we know, that is tetrahedral, because it is sp3 hybridized. We can represent bond structure like this: carbon having 1 hydrogen and 2, the 3, and all 4 bonds actually should be written in same length, because the bond length of this will be only, bond length is 108.7 picometers. All bond lengths, this bond length, this one, all CH bond lengths will be of same 108.7 picometers, and bond angle, because it is sp3 hybridized, we know 109.5 degrees, right? So this can be represented your bond angle, and this can be represented with the bond length, right? So would like to show next structures of some compounds. How to write the structures of the alkanes. For example, if you take methane, it's a condensed formula or molecular formula you write, actually this is CH4, right? And actually to represent bond line formula, here R4 should be attached to the carbon, not in the air. See, they should be near to the carbon and hydrogen. This is called your bond line formula. Similarly, you can represent ethane, C2H5, or I can represent CH3, CH3. Its formula is C2H6, right? I can represent CH3, or if I want to expand completely, I should write like this. Isn't it? And next one I can take propane in this series. Its molecular formula will be C3H8. You can represent CH3, condensed formula we call this one, CH2 and CH3. Ending always alkane should have CH3 because carbon with 3 bonds here and 1 bond with the other carbon. Look at 1, 2, 3, 4. Wherever you count, you will get 4 bonds only. That is your tetravalency. If you want to expand this, see again you have to write carbon, hydrogen. Like this you have to expand it. Here, see, that means middle carbons are all getting the CH2s. This is bond line formula you call. This is condensed formula you call. Similarly, if we go for higher alkanes, for example, butane, the chain length will increase. If chain length increases, it is very difficult for us to write this bond line structure. Just for your sake, I am representing here. Here all middle carbons are getting 2 hydrogens. End carbons are having 3 hydrogens. 1, 2, 3. See, middle carbon CH2. You can find here clearly middle carbons are CH2 because 2 hydrogens and 2 carbon atoms. So on the whole again 2 carbon gets the 4 bonds. Actually you can say this propane, butane, ethane they are derived from the compounds, previous compounds. For example, if I remove 1 hydrogen and keep CH3, I will get the ethane. And from this, if I remove 1 hydrogen, if I substitute CH2 in between them, I will get the propane. 1 more CH2, I will get the butane. 1 more CH2, I will get the pentane. Next, hexane, like that. That means these are from propane to the next, they are differed by 1 CH2. And these are called as homologues or homologous series. The compounds which are differed by CH2 are called as homologous series. The most important thing I would like to tell you here, other representation of this compound is line representation. For example, propane I can represent like this, whereas butane can be represented like this. What is this? Line formula. Because it is very difficult for us to follow this line bond structure. Every time writing hydrogen carbon, it is difficult. Sometimes we will write like this. Even for higher compounds, this structure is also difficult. So we follow this one. Here 1, 2, 3. And this is your 4 carbon atom long chain. So this indicates that CH2, end carbons indicate CH3s. So in this there are 2 CH2s. Again write the bond length similarly. If you measure also, it should be of same length. Okay, you should not write like this. This won't be a butane. Okay, this is wrong representation. To be correct, you have to. For example, for pentane, how you will represent? Like this. Hexane and so on. It is very difficult to write full structures or condensed structure in your reactions when you are discussing. Therefore, please try to practice this line structure for all the compounds. You should get in your mind, even though if you write, you should get in your mind like this or this structure of the propane. If you write this one, you should get in your mind, this is a pentane. Pentane structure is this. It's a molecular formula, bonds, everything should get in your mind. Right? So, we practice this compounds. And if you want, try to write what are the names and you can expand their structure of these compounds. If you are eager, try to write their compounds structure and the name etc. for them. Okay, now we move to the next topic, that is nomenclature. Nomenclature of alkanes. Actually, nomenclature you have studied in the first year only. Just it is practice revision for you. I will not go very detailed into the all rules of alkanes. Just whatever important I would like to go. So first one, any organic compound for IUPAC nomenclature. What is IUPAC? Get yourself, right? IUPAC, an important nomenclature which everybody used in the all over the world, right? So in this we have two parts. For every IUPAC nomenclature of a compound, we have two parts. What are the two parts? One will be prefix. What is this prefix? This prefix indicates the number of carbon atoms. How many carbon atoms are there? That will be indicated by your prefix. Suffix. This will be indicate the chain structure. This indicates the chain structure. That is, for example, if it is alkane, suffix will be end with "ane". If it is alkene, the suffix will end with "ene". If it is alkyne, it end with "ine", like that. Okay, so important rules to be recollected. So first rule of this nomenclature is the longest carbon chain of the molecule is identified. And the second rule is the numbering is given such that branched carbons should get lowest possible number, right? And more important things, alkyl substituents. Alkyl substituents should get least number, and they are attached to the branch, are prefixed with parent chain. Prefix means before we have to call. See, here prefix we said number of carbon atom. For example, here we said prefix means number of carbon atoms. I said if it is 3 carbon atoms, prop I call. But before calling prop, the substituents should be pronounced first. That means if it is present methyl group on the third position. So 3-methyl propane, like that we call. I hope you know all this, just recollecting. I'm writing all together, that's why. I'll give some example later. And substituents are indicated with, these substituents are indicated by numbers. I should know where they are, right? Which position they are. 3-methyl, 2-methyl, like that I will say with numbers what are where they are present, right? And if two or more substituents are present, then they are separated by columns, commas, and prefixed as di, tri, etc. For example, 2 or more same substituents I should call. 2 or more same substituents are present, I should call prefix dimethyl. I just now said that substituents are prefixed before the parent chain. Methyl propane చెప్పాలి. అలాగే రెండు సిమిలర్ కాంపౌండ్ సబ్స్టిట్యూయెంట్స్ ఉంటే డైమిథైల్ అనాలి. అవి సిమిలర్ గా ఉంటాయి. ఒకవేళ డిఫరెంట్ గా ఉంటే, ఇఫ్ 2 substituents are different, then how to call? We have to call by their alphabetical order, right? Alphabetical order and that should be given lower numbering. For example, if ethyl substituent is there, if methyl substituent is there, ethyl should be given lower number and alphabetical order given its name first. I would like to write what are that alkyl substituents first. See, if CH3 attached to my parent chain, I call it to be methyl. Actually, this is derived from the methane, right? One hydrogen is removed and some substituents, some other carbon is attached, right? Therefore, it is coming from methane. Therefore, I call it to be methyl. For example, if CH2, CH3 is there, CH3, CH3 is ethane. So, one hydrogen is removed. Therefore, I call it to be ethyl, isn't it? Similarly, propyl and all. But you should know CH3, CH and CH3. If this substituent is present onto the chain, see here, this is chain. So this is my substituent, 3 carbon, that too second carbon chain is attached. This is called as your isopropyl. Common things I'm saying. And butyl what? See here, CH2, 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 CH, if it is present, butyl. But if onto the butyl, my chain is attached to the second carbon of that butane, then I call it to be secondary butyl. Right. For example, carbon is having like this, butyl structure is like this. See here, if one carbon is attached, 3 carbon chain in line and one is attached like this. And if my parent chain is attached here, then I call this one as tertiary butyl. Okay. So please remember these, sometimes we will get in our compounds. Before giving the nomenclature rules, structures, I'm telling you what are the substituents are present in the compounds. Right. Let us take some examples. So I would like to write your line formula only. So where I should give the numbering and where you have to, what is the name of that compound. So first, what is our rule? For identify the longest chain. So here 1, 2, 3. So here, let me write 1, 2, 3, 4 and 5. Yes, 5 carbon chain. Actually, if there would be some from this side, if you count also 1, 2, 3, 4, 5, it will come. But if I write like this, then which is the long chain? 1, 2, 3, 4, 5. This should not be taken. Ante madam 1, 2 second position lo propyl ani cheppochu kada, 2 propyl pentane ani cheppochu kada. No. Let me finish this. See here 1, 2, 3, 4, 5. On to the second position, methyl group is there. See, if I write, this is CH3, it indicates. Right. So 2 methyl, 5 carbons. Therefore, my suffix will be pentane. And see, actually, ane is my suffix, pent is my prefix. Before that, substituent is given with its number. See here, pentane is prefix, suffix, both contains. Ane because all single bonds. Pent because 1, 2, 5 carbon atoms are present. So pentane. But onto the second carbon, there is a methyl substituent. Able to recognize? This one line I am representing means this is CH3. I have written row here CH3. CH3, if it is represented, CH3 means methyl because it is coming from the methane, right? So this is methyl. I have to indicate, imagine in my mind and write. Even though if I don't write CH3, I should get CH3 it is, right? So CH3 methyl pentane. For example, here I should not count. This numbering is wrong. 1, 2, 3, 4 numbering is wrong. So which is correct numbering then? From here 1, 2, 3. This is 4, 5 and 6, 7. This is the correct numbering. Because longest carbon chain comes from this but not from here. So if I write on the straight line, you should not find that this is the correct one. Whichever the line I write, you have to find yourself the longest chain, right? So heptane will be coming. My prefixes, suffixes will be actually heptane. Then one substituent is present here in which position? This fourth position. Therefore 4-methyl I should say. 4-methyl heptane. Right? That is the nomenclature of this compound. Then lowest sum rule. I will give you some more examples. You practice it at home. Lowest sum rule. One example let me take. 1, 2, 3, 4, 5. Right? Or let me write clearly. 1, 2, 3, 4, 5. If my substituent is present here and here, this is my compound, then what is the name and how you have to give the numbering? Shall I give the numbering from here? So 1, 2, and this is the third, fourth, fifth. 5 carbon atoms, and I choose this one as pentane, and second position 1 methyl group, third position another methyl group. Therefore I should name this compound as 2,3-dimethyl. But there is another chance of writing this one in another way. What is that? Numbering is this one from left to right. May I give numbering from here? 1, 2 and 3, 4, 5. See here, if this number I have followed, this is from right to left. Right? From here to this side it is moving. So this is not correct. Only this is correct I am saying. Because already we know that substituents should get the least number. Substituents always. For example, here you see, I am saying 2-methyl. I am not saying from this 1, 2, 3, 4. 4-methyl pentane I am not giving for this name. Right? And for this also 1, 2, 3, 4-methyl I am saying. But here 1, 2, 3, 4. Anyway this is coming 4-methyl only. Correct? So substituent should get the least number, right? So here also if I say 2,3-dimethyl, 1, 2, 3, 4, 5 pentane. Right? 2-dimethyl, this is correct. I should not say, if I write like this, this will be 3,4-dimethyl pentane. This I should not call because this is wrong. Because if you count 4 plus 3, this would be equivalent to 7. Right? But whereas if you count this, this will be equivalent to 5. So 5 is the least number than 7. Therefore, least sum rule. Sum means addition. You add those substituents numbers wherever you are getting doubt. Then whichever is getting the least number, that will be given. That side numbering will be given and pronounced with their respective before the prefix. 2,3-dimethyl will be correct for this.